Hello everyone, Mr. Boltri here, bringing you video 2.10, where we're going to be talking about the Unit 2 practicum, which we will run in our next class. So after you come back from fall break, either Thursday or Friday in class, we are first going to start by taking quiz 2D on shifting representations. And when we're done with that, we're going to dive right into the practicum. So that should give us probably about an hour to work on the practicum, which should be plenty of time. But I wanted to go ahead and get most of the introduction stuff out of the way so we can hit the ground running and make sure we finish the practicum in class on either Thursday or Friday. Because then the following week, either Monday or Tuesday, depending on when you have class, we're going to have a day for review, just so you can look over your quiz, ask questions, do extra practice problems before the test, which is going to be the following Wednesday, October 21st. So that's what the rest of the unit looks like. And I just want to make sure that everyone was prepared to crush the end of the unit stuff. So about the practicum in particular, it's kind of a fun practicum that involves taking two cars and then crashing them into each other and seeing where they crash into each other. So for this practicum, you will be given two cars. I often do a red car and a blue car, but we might have to mix it up a little bit this year since we have so many groups. But you will be given two different cars, which should hopefully have different speeds. And then you will drive them towards each other until they crash into each other. So, the goal will be to determine where exactly they crash into each other. So is it at 0 tiles or 1 tiles or -2 tiles? And you have to decide where they are going to crash. And then we can test the prediction to see how close you actually were. So the practicum comes in two parts. The first part is I will give you the cars. And after I give you the cars, I'm going to ask you to determine the speed of each. And obviously, you won't know the velocity because I'll tell you later if it's going to be moving in the positive direction or the negative direction. But you can determine the speed, which can then help you later. And then after you've determined the speed of each car, and you'll have to write it down clearly on your sheet so I can know that you're doing a good job, then I will give you the starting positions and the directions of each car. So I will say this car will start at -3 tiles and move to the right. This car will start at +18 tiles and move to the left. And you have to determine then where they are going to crash. Not when. When might be useful also, but specifically where, at what position, at what tile they're going to crash into each other. So some things to think about to make sure that you're prepared to crush this practicum, because it's kind of similar to stuff we've done in the past, but not exactly the same as things that we've done in the past. So one thing that I need you to come to class like really prepared to do a good job with is to figure out what is the best way to determine the speed of a car. So a lot of people are just tempted to say, well, if I can figure out how long it takes to go one tile, then I can do some math and then I have the speed. But you might think about, is that the best way to determine the speed of the car? Because you might be opening yourself up to some errors, because if you only take the one measurement at the one distance and the one time, then you better hope that that measurement was really accurate, or else your final results are going to be wrong because you didn't take into account maybe more distances or more times. So I need you to come in with a prepared plan for the best way that you and your team are going to determine the speed of your car. And the other thing is, it really helps students, I think, if they envision the two cars starting at different positions and then driving towards each other and then crashing into each other. And what does that look like on a position versus time graph? Because then if you have that image really solidified in your mind, then the practicum becomes a lot easier because you're not having to try to figure out what the heck is going on. So if you can think about these two questions before you come to class for the practicum, I think you're going to be really prepared to do a really good job on the practicum. And to that end, I've actually made an optional worksheet that you might want to fill out. You might want to fill out, you might not. If you can answer these questions really easily, then you can just come to the class and crush the practicum. But if you want to feel extra prepared, you can complete this optional homework 2.10. Which just goes through basically those two questions. It tries to get you to think about what is the best way to determine the speed or the velocity, and then what will the qualitative, you won't have any numbers yet, but qualitatively, which means without numbers, what will the position versus time graph look like for this scenario? So if you do take the time to answer these two questions, I think the practicum is going to actually be relatively easy. And if you don't, as long as you're watching this video, so you're already thinking about it, so you're already ahead. I just know it's going to be a really tight class with the quiz and the practicum. So I want you to come to class feeling really prepared and ready to do a good job and do the best of your ability. So as always, let me know if you have any questions. I'm looking forward to doing this practicum with you in our next class. But until then, go Bears.